Hi, this is video 4. In this, we're looking at the expected value of a product, right? So the expected value of a product xy, where x and y are two random variables, in general is not a product of expectation. So in general, for all random variables, this does not hold. But if we know that x and y are independent of one another, then the expectation of x of y is equal to the expectation of x times the expectation of y. Right, so this is known that they are random. These are independent random variables. We can quickly prove that. So proof is that the expectation of x and y by definition is this. So we already know this part, right? We know that this is by definition, right? Is the joint probability distribution for x and y times the values for x and y, the joint values for x and y, right? But now we have the assumption of independence. So by the assumption of independence, we can say that this joint PDF is equal to, and this is known to us, right? So this is known from prior knowledge that if x and y are independent, this condition holds. So we can substitute that in this equation here, right? So we'll get expectation of x and y is x in x and p of x times x, and I'm just rearranging terms, right? And then the summation y in y such that py of y times y, right? And so by definition, I know that this is the expectation of x, and I know that this is the expectation of y, right? So the joint expectation for x and y is e of x times E of y, right? So this holds for all independent random variables. Let's say two independent rolls of dice, right? And then we're looking at the joint expectation of x and y. That is equal to the expectation of x times the expectation of y. Okay, so moving on to sum of indicators, and a good way of understanding this problem is using this hat check problem. So let's look at this, right? A new employee at a restaurant checks the hats of n people, forgetting to put claim check numbers on the hats. When all customers return for their hats, the checker gives back a hat at random. What is the expected number of hats that are returned correctly? So essentially, we're trying to find the expectation of the number of hats, whatever n is, are returned to the right person, right? So let us begin with defining our random variable. So x is the random variable that represents the number of people who receive the correct hat, right? So random variable that represents number of people receiving the correct hat. Okay, that's x. And if you think about what's happening, and this is x of I, is the random variable if some ith person receives the correct hat or not, right? So the first person received the correct hat or not, the second one received or not, third, and so on. So I'll get if I get the sum of these, that's equal to the number of people receiving the correct hat, right? So this is if the ith person receives the correct hat or not. Or maybe think about this as the indicator variable, right? So x of I is 1 and x of I is 0. 1 if the person receives the hat, 0 if not, right? So what is the probability of the ith person, although we've done that before, so I'm still looking at it again. Probability of the ith person receiving the correct hat, which is p x of I, which is x of 1 actually, so p x of 1 or x of 0, both are going to be 1 over n, right? So, and this is just a review of what we have looked before. So e x of I, or whether the person received it or not, is going to be 1, either 1 times the probability when x1 plus 0 times p of x0, right? So this is 1 times 1 over n plus 0 times 1 over n, but that's 0, so this is going to be 1 over n. Right, so we have seen that before, but just a review. And then I'm interested in the expectation of x, which is by linearity of expectation, x1 plus e of x2, and so on up to e of xn, because there are n people, right? So that is going to be n times 1 over n, which is 1, right? So if you look at it, the average number of people receiving the correct hat is 1. And more importantly, in this problem, we can see that this is independent of the number of people who have checked in their hats, right? Because we are getting e of x equals 1, right? And this is independent of n. So we don't care how many people walked in. It's just that one person is going to receive the correct hat. Okay, so with this, I end this video. In the next video, we are going to talk about variance.